Welcome everyone. So let's continue from our data manipulation session where we left. Just to reiterate where we had left our last session, what we completed in data manipulation is how do we go about selecting certain observations or selecting certain columns. For selecting certain observations, we saw the which filter, and we applied the subset. These are the two commands that we saw. If we want to select certain columns, then we have to specify the list of column names that we would like to select. Either column names, or we can go with the option of specifying the column index positions. Then we also saw how we can dynamically select if the variable names are given dynamically. Then we can have that as part of a comparison. If there is only one variable to be compared, double equal to be used. If there are multiple columns to be compared, then percentage in percentage to be used. Drop, basically if I have many columns and from that I want to drop only 2 or 3 columns. In that case, we just use the same syntax as we have where equal to or in comparison is there. Only thing is, after that we just add the exclamation mark, so it negates the entire thing. Okay, so this is what. Then merging data, we saw different types of merge: inner join, left join, right join, outer join, cross join. So, and we also saw that while we were doing cross join, to some extent, if your column names, which is the by identifier, is common and you forget specifying the by clause, R intelligently detects the common identifier and then tries to merge it. The problem arises when the column identifier, which is the common identifier between the two data frames to be merged, if that is not common, in that case you get a very random output. We tried executing a cross join where we had cust ID and CID, both representing customer ID. And when we tried merging 20,000 records with 19,000 records, I had to shut down my machine and restart it. Yeah. So when we are merging, we have to ensure that we give appropriate by clause. Then renaming column name, we also understood why it is important to rename. Giving appropriate self-explanatory column name helps. Converting variable type, casting. And when we did casting, I specifically mentioned that when we are casting integer, there are two ways to cast. One is either convert an integer to character and then cast it to from basically a factor, a column which is of type factor but containing integer values. If you have to convert to integer, we have to first cast it to character and then to integer. Or the other approach is use levels. Both the syntaxes are given here. Then we saw data sorting, aggregation. So we did frequency aggregation, basically table to get frequency, and the table command, if you pass two columns, we get a cross tabulation. And when we did cross tabulation, I explained the concept of row proportion, column proportion, overall proportion. And there was a homework given, okay, how to find out that column or that function by which we can get a one output. I hope you got that function name. Actually, it's a G models package which contains a cross table function. If you directly use a cross table function, it gives you the required output. Okay, these were the various things. And aggregation, this is where I introduced the SQL DF, because one of the common ways of doing aggregation is using SQL DF package, and many people are conversant with SQL syntaxes. So R provides you a framework, a package SQL DF, wherein if you use that, you can directly write NC SQL syntaxes and get the required output. Let us just write one more syntax, which is using a plier package. Okay. In R, plier is one of the most used package, commonly used for aggregation. So let me just explain this plier package, how aggregation happens. So this is a simple syntax. I load the package using plier, library plier. Then I use this plier function ddply. So this dd says that there are two dd. The first input dd is to say that is a input data frame. The input is a data frame. The second is says that this is the output. I want the output again as a data frame. So this way what you can do is there are many other versions of this command. You can write dlply. So input will be data frame, output will be list. So ddply. So now this ddply is used for doing aggregation. Now when you have to do aggregation, first you have to specify on which data frame you wish to do aggregation. So the first parameter is that. Second, you have to specify what are the dimensions. So this is the second parameter. Okay, so I want to do aggregation at age bucket and gender level. Now the third element is when you are doing aggregation, you are actually summing up measures. So I am specifying sum of balance, min of balance, and max of balance. Now this is a syntactical element, function df. You can give any name for instead of df also. Okay, you have to write this function df. What happens when you call this package, this function? The first thing is, based upon this dimension, age and gender, the entire data will be broken into many smaller sets of data. So age less than 25 and female, that combination will become one set of data. Age less than 25 male, that becomes a one set of data. All records which satisfy the criteria of age and gender and whatever combinations are possible. So those combinations, separate data sets will be formed as this logic executes. Each set is then passed to internal another function, and when it is passed to another function, that subset of data is named as df, because I have given the name df. If you say abc, internally it will be called abc. And then the aggregation happens. The aggregate output is given back. So each subset aggregation happens, and once you have got aggregations of all these subsets, they are appended to each other and you get the final output. Okay, this is how the calculation internally is happening. Yeah, so let's just try out this syntax. All of you type on your screen and execute it. I'll keep this open for you.
Sorry, I understood the importance of calling the function df.
Okay, so plier is one of the most used packages, and if you're not comfortable with SQL, then probably you can use a plier package and do the aggregation. Here I have shown couple of more syntaxes. We'll not try those syntaxes, but I'll just explain. In the previous slide, when I executed, these variable names came as v1, v2, v3. In case you want to give suitable variable names, in that case what you can do is you can say variable whatever name you wish to assign is equal to the aggregation function. Variable name equal to the aggregation function. Variable name equal to the aggregation function. And in that case you see all columns are properly named instead of v1, v2, v3. Okay. So these are a couple of examples that I have shown here. Now let's move to apply family of functions in R. In R, there are many functions which is called as apply family of functions. The functions are apply, sapply, lapply, tapply, mapply. When I say tapply, it means the output would be like a table kind of a thing. Mapply, the output would be like a matrix kind of a thing. So there are lapply is list. So there are various kind of apply family of functions. This is the first basic one. So here what I'm saying is this is the data frame, two specific columns I'm passing. I'm using the number value 2. So here, as I said, in R we have row position and column position. First is row position, second is the column position. So here the moment I say value 2, it means the function mean on these two columns have to apply by column. If I would have, instead of putting the value 2 here, I would have put the value 1. What it would mean is this column and this column average, and it would do row wise. So let's see the syntax and let's execute it. I'll try to break down this code into multiple things. Here, if you see, when I say data.frame, this part of the syntax, what it means is take two columns and create a new data frame. Yes, what is the object? Put it in that position. It is as good as set. So let me just run it. It will show me some 500 observations. So it shows me 500 observations of that. And then it says that, okay, omitted another, but there are 20,000 observations. Now I can do averaging like this. This number and this number, I can do averaging and get a new number. Or I can add all these numbers like this: 2715, 2715, 3663, 8233, like this I add them and do average, which is column wise. If I want to do column wise, I am saying that 2. And if I want row wise, I will say 1. Basically, the advantage of this is, if you want to apply a certain function, say the mean function, on a series of columns, on a number of columns, the way I would have done is, I would have run mean df dollar balance. Now there is another column on which I have to do mean. I would have done it like this: dollar number of. Then I want a mean of some more column, age. I would have kept doing it like this. But if you want to do mean for number of columns in one go, rather than typing it one by one, this is apply. In the background, what is happening? This is exactly what is happening. Yeah. And there is a, by different ways, I could have, instead of typing these two columns, if I wanted to get all the columns which are numeric, if I want all columns which are numeric, I could have got that also syntactically. Rather than typing names of each column, using some syntax, if there is a data frame having say 500 columns and I want mean for all the columns in one go, using some syntax I could have identified all numeric columns and write that syntax here, which is in the highlighted place. All numeric columns would have been selected, okay, and would have come here, and using this apply, mean for all of them would be computed in one go. Yeah. So let's run this simple syntax. So here when I run it, you see I'm getting mean, which is by columns. Yeah. Just try this. One line of code. Let us see what would have happened if I would have put 1. Okay, it will give me some 500 observation, and then it would, okay, they are omitted 19,000 observation. What it has done is took the first row balance and number of credit transaction, added it, divided by 2. But does it make any sense to add balance and number of credit transaction? Balance is in rupees, number of credit transaction is count of transaction. It does not make sense, right? What would have made sense is if I wanted to know what is the average ticket size per transaction. Okay, assume you have written a function which does balance. Instead of saying balance, it is number of withdrawals, amount withdrawn. Assume the column is amount withdrawn and number of transactions through which that amount has been withdrawn. And now you have written a function, say ATS. ATS is a function which will do ratio of amount withdrawn divided by number of transactions. In that case, you can put your function here, ATS, average ticket size, and here there would be a column saying whatever this ATS would be your user defined function, which requires two input. One is withdrawal amount and number of number of debit. If it is a withdrawal, it would be number of debit, right? And that function will take the two parameter row by row. It will do the calculation and it will give a value for each row. In that case, doing calculation row wise makes sense, right? But when it comes to mean, in this case, it does not make sense. Or if you would have this column balance of last month, balance of 2 month back, balance of 3 month back, and now you want average quarterly balance. So basically in your data row wise, these three are there. Now you want average quarterly balance. Then again doing row mean makes sense. Yeah. So just by changing option 1 or 2, you can do the calculation.
So option 1 is like column wise?
Row wise.
Row wise.
1 is row wise.
Okay.
Option 2 is column wise. So whatever is the name of the function which comes here, that function either you want to apply row wise or column wise. If you say 1, then all the values which are here, all the columns that you specify, that function will apply row level. If you specify 2, that function, whatever function name you specify here, will apply column level.
So just to put this in perspective, if I have a mini statement from an ATM, and I can see a person is withdrawing only 500,000 rupee more on every transaction.
So just like apply, we have a lapply function. So here what I'm doing is I'm doing lapply mean, and again some syntax I have given. I'm now trying to dynamically select column names and then applying mean. By default, mean will apply column level only. Okay. So here, which all columns in this LRDF data frame matches with age or score, those columns will be selected. And on those columns, the mean function will be applied and I get this output. So let me try this syntax, which is my lapply. This is the second one. This returns a list. So and this is the output. Likewise, the same thing, instead of using lapply, if I used sapply, this output you see has come as a list. Yeah. Instead of using lapply, I would have just changed this s and make it sapply. The output would come as a data frame vector. It would come as a vector. Okay. So just the reason why you have these various words L, S, basically just to say what type of output you want. Okay.
L stands
L is list.
less.
L stands for list. Lapply, output will come.
S is?
S is for vector. Just let's see a simple practical application of this kind of a thing. Say I just want to find out all columns which are of type numeric. I want to create a data frame where all the numeric columns I put in a separate data frame. So here what I'm doing is lapply class. What will this lapply class will do? On this LRDF data frame, for each column, it is going to apply the class function and return me back whether it's numeric, integer, character, factor, string, whatever. Now this, it will then compare with, because my interest is only numeric columns and integer. Integer is also number. So I am now comparing those class types with this. And whichever comparisons are matching, there it will become true. Wherever it is not matching, it will become false. So let us try to execute this code piece by piece. So here, when I apply this lapply, it is going to return me a list, because lapply list. Okay, so it is returning me that cust ID is a factor, target is an integer, age is an integer, gender is factor, and so forth. Now this I'm comparing with numeric or integer. Now wherever that comparison will match, the corresponding value will be returned. So the first one was not numeric or integer, so false. True, true, false, true, false. Now whichever column position, now this vector of true and false is in the column position. So whichever column it matches with true or false. If it matches with true, that column will get selected. If it is false, that column will not be selected. Now those columns will get selected from here, and I'm now putting it in a data frame where all numeric columns are there. So I just named it data frame numeric. So this is like a application. Okay. So if I run this and then do head, you will see all numeric: target, age, balance, number of credit transactions, score, holding period. These are my numeric columns, numeric or integer. They have got separated. Yeah. So this is how you find practical applications. Depending upon your scenario, you have to find your own practical application, which function may be of useful. When apply family of function can come into play, when subset can be used, when plier can be used, when SQL DF can be used. That is all up to you to think. What I am doing is I am introducing you to all these various type of functionalities and syntaxes. So the next element is basically tapply. So it returns basically here what I'm doing again, tapply mean. And now what I've done is, if I want one dimension and another measure, with respect to dimension and the given measure, I want to do some aggregation. So here I'm using a tapply. So here you see I specified score is my measure, age is my dimension, and mean is the average aggregation function. What I'm saying is, by age bucket, for each age bucket, give me what is the average score of customers in that age bucket. Score is a column where we have captured some risk score or a marketing score. So I want to say every age bucket, what is the average score of that bucket. If I want to do it in a two dimension, so here I'm saying age bucket by gender, I want to know what is the score, or probably we could have said balance also. What is the average balance maintained by females less than 25? right? So yeah, I would have said mean function instead of using score. I could have put balance also. So tapply gives you cross tab. By default, when we use table, if you recollect, when we use table, table gives you count. When I do a cross tab of table using a table function, it gave me count of records in that. Here I don't want count of records. Here my objective is to say mean or something. So I can do using a tapply function, and I can change the function here. If I want sum, I can put sum. Any aggregation function that you want across that dimension and measure, you can put it here. Yeah. So this is a tapply. So let's run the syntax. So tapply, when I run it for say score, this is a step. It gives me this kind of output. When I run it for 2 dimensions, it gives me a cross tab, and in the cells which are the intersections of that cross tab, I get the mean. Yeah. What if this mean tapply is not there? Okay, what would be your other options? You could have done this using a dplyr package, using some ddply function. In ddply function, you would have said you want to do dimension is age bucket and measure is basically score, and then you would have said mean. Okay, if you do not use dplyr, you use SQLDF, what you would have done? You would have written something like this: df SQL df bracket, and then you would have written a full select age underscore bucket comma mean SCR from LR underscore DF group by age underscore bucket. Something of this syntax you would have to write. Now, if you are not a person who knows SQL, if you are not SQL guy, you will not be able to write this syntax. In that case, this is a simpler version for you. Are you getting? So R is providing you multiple ways to do the same thing. Now it is up to your comfort. Are you okay with the R syntax? Go with R syntax. If you are comfortable using SQL syntax, write a SQL syntax in R, get the output. So now let's move to functions. We have already used some of the aggregation functions, sum, mean, min, max, we have already used, but let's see some of the most commonly used mathematical functions, some of the commonly used summary functions, string functions, and if there is a function which is not available directly, then how can we go ahead and create our own user defined function? Okay, so let's see them. So a basic summary function, we have already used summary. If I run summary, all columns in one go, it gives me a summary of all the columns. So let me run summary function. Summary LR underscore DF. In one go, for all columns it has given me. So for the cust ID, the first column is cust ID. It says C1, 10, 100, 1111, others 19,994. Because all values are coming 1111, and then it is saying other 19,994, I can assume that this is my identifier column. Because if there would be certain records which would have come multiple times, at least those records it would have shown 2, 5, 10 here, instead of just showing only those columns which are those values which are coming one time. And then it would have said others. So this is my identifier column. target, because I know target should be 0 or 1, so it says min is 0, max is 1, and then it's giving first quartile, median, third quartile, and so forth, but I know it's a 1-0 kind of variable. Okay. Age, it says min is 21, max is 55. First quartile 30, median 38, mean 38, third quartile 47. Now why do we do all these things? Specifically, we do this as an exploratory data analysis to do a quick data quality check. If I want to know whether all variables are in range, just assume that you have asked your team member to extract data of customers to whom you wish to run a campaign. And you mentioned that the data should be of all customers who are between 25 years of age and 55 years. So range is 25 to 55. That is one of the criteria you had given. Because you don't want to target anyone who is less than 25, anyone who is greater than 55, you don't wish to target. The person runs all the codes and he gives you a final data frame. Now you don't have much time to do checking. One way of checking is you sit with the colleague, see his code and see whether the conditions are rightly written or not. But that type of quality check may not be of help, because in that case you're virtually going through the entire code. So the other way is you can have the data and you say, okay, I'll just quickly run summary. Summary gives you min, max, quartile distributions. By just seeing that range, if any age comes which is less than 25, say even one record, but it will say min and that becomes 21, you can understand he has not applied the filter properly. Similarly, if you would have asked that I want some filter on other columns which are categorical, say your objective is to target only females because probably you are running that campaign on a Women's Day. Now all of a sudden you get observations where there are male and others also, which means again that filter was not applied properly or some data processing error has happened. So the reason why you do the summary is as an exploratory data analysis. One is exploratory data analysis to understand the data better. Second is for quality check. Likewise, you can have other reasons why you want to quickly run a summary and get the output in one syntax. Yeah. So summary helps you do that. Just try and run the summary function. Now if I want to run summary function, instead of running the entire summary function, I don't have time to run the function for whole data. For example, you are in the middle of analysis and your data set has got 500 columns. And if you run summary for 500 columns and if you are say millions of record, it is going to take longer time. If you want to run the summary function only for a specific column, you just say the column name and run the summary. Other way of getting summarized information is you want a frequency distribution only for a specific column, because see summary also gave you frequency distribution. Occupation, it gave you this entire frequency, right? But I don't want for all columns it should compute because it is running for continuous and categorical all. I want only specific column. Table, we have already seen it. Now sometimes you want a finer detail about data, that is called percentile distribution. So there is a function called quantile. If you run it, the syntax is the numeric column and then you specify the percentiles you wish to have. Typically when we take percentile distribution, we say 0, 1, 5, 10, 25, 50, 75, 90, 95, 99 and 100. This is the combination we typically try to see. 50, what is 50 percentile? Median. What is 25? First quartile. 75? Third quartile. In statistics, we often see interquartile range, that is 25 and 75 the difference between that is called interquartile range. Okay. Again, why you want 1 and 99? See the numbers, the way the numbers are stacked. 0 means minimum, 100 means maximum. 1 is many times you see data at 1 percentile or 99 percentile. If you understand hypothesis testing, many of the hypothesis testing is at 99% confidence. Okay. T-tail test. Tail test. Okay. Basically like when you do histograms. Typically the histogram is this is what you have. This is your median. Then you will have 1 percentile. You will have 99 percentile. So both sides I am taking 1 and 99. Quite often you are not interested at 1 percentile and 99. You are doing things at 5% confidence, 95% confidence. So when I say 5, on one side if it is 5, the other side becomes 95. So that's the way numbers are selected. At times you are interested at 90 percentage. So 10 and 90. So it becomes 90 here. Likewise 10 on the other side. Then is interquartile, first quartile and third quartile. So I've got 25 and I've got 75, and definitely the median is 50. So this is how that this numbers are selected. Typically, if you want, say I want 60 percentile also, nothing stops you from typing here 60. Just go ahead and type 60 and you will get and 40 also. If that is your requirement, go ahead and type those numbers and get it. Yeah. The key is now interpreting. Interpreting these numbers is the key. So here when I see the numbers, quick interpretation is my median age of my customers is 38. What it means is 50% of my customers are less than 38, 50% are above. Yeah. So that is the interpretation of median. Many times by seeing these numbers, I can identify outliers also. How we can see outliers? Let us run this code for balance. Let me erase all these things and let us run the code for balance. Now let's take this balance column, Control R. Now just focus everyone. Balance column, when we see that output, so here if you see P99 is 7,23,000. From 0 percentile to 99 percentile, the value has ranged from 0 to 7,23,000. But now from 99 to 100, you see the value is increasing from 1,24,000 to 12,46,966, and the 99 is 7,23,000. The difference is 5 lakh. In 1 percentile, the value is jumping 5 lakh, and for 99 percentile, the range was only 7 lakh something. This is outlier. This is how outliers are determined. If there is a sudden jump in value, in that case you say that it's outlier. Now whenever there is a outlier values, typically the rule is most of the time we do capping and flooring. When it comes to capping means upside is to be capped. Typically we do capping at 99 percentile most of the time. At times you may want to go at 95 percentile also. And when it comes to flooring, for example, this balance here in my data, it's 0. It is quite possible you may have one customer having -1 lakh and -2 lakh also overdrafts. Because of overdraft, you could have one customer having minus 2 lakh also. Assume this range on the lower side would have gone minus 5,000, 7,000 also, and all of a sudden minimum is coming but minus 2 lakh. And P1 is coming as minus 2,300. That range is also wide, 2 lakh and minus 2,000. And the rest of the 0 to 99 is 7 lakh. So again, that range is wide. So in that case, what you will say? Floor it, right? So what you will do, minus 2 lakh, you will bring it to minus 2,000. Or you may take a business call, okay, any value which is negative, I want to make it 0. Yeah, so that is called flooring. So typically we take a call at P1 and P99. You may at times take a call at P95 and P5 also, depending upon your business requirements. And this is why we see these frequencies and percentiles. I again lay stress on this fact. Exploratory data analysis, when it comes to exploratory data analysis, the concept is very simple. First, you do a univariate analysis. Univariate means one variable at a time. When it comes to one variable at a time, categorical variable is always seen as a frequency distribution. So you see frequencies and you convert them into proportions. Okay. When it comes to continuous variables, we always see percentile distribution. At times from one variable, univariate, you may go to multivariate also. For example, if there are two categorical variables, you may go ahead and create cross tabs also. So this is the basic analysis that we first do before going into in-depth model development. Okay. So these are some of the functions which you will often use when you're doing EDA, exploratory data analysis process. So just try out these syntaxes. Now let us see some mathematical functions. We have done some summary functions. Again, when it comes to mathematical functions, first thing that I would like to tell you, mathematical or text manipulation functions, all tools work the same. In Excel also you can find all the functions. In SQL also you can find all the functions. In SAS also you can find all the functions. So what the point is, any mathematical function which is a standard function, sine, cos, tan, available. Trigonometry functions, available. Financial functions, computing present value, computing internal rate of return, available. In R also, in Excel also, in SQL also, in SAS also. Yeah. So here I'm just trying to introduce certain basic functions and just to show that these functions are available. So what I've done is, in this syntax I'm doing ceiling. Ceiling 2.4, 2.4, 2.4, 2.4. So what will be the ceiling of 2.4? When I say seal, what will be the value of 2.4? No, ceiling of 2.4 will be 3. Floor of 2.4, 2. Round of 2.4 will be 2. And truncate of 2.4 will be 2. Truncate is remove the decimal. And ceiling is go to the next higher integer. The ceiling is go to the next higher integer. Floor is round and come to the next lower integer, immediate lower integer. So similarly, if I do 2.6, ceiling will be 3 only, floor will be 2 only, trunk will be 2 and round will be 3. So this is just to show these functions. And if you go to if you go to Excel and use these same functions in Excel, output will be same. Okay. Absolute in R or Excel or SQL is absolute. Remove the sign. Square root means square root. Exponential means exponential. So such a big number. Log is, exponential is basically E is a natural constant. there's a number called Euler's constant, which is called E. The value of that is something called 2.7 something. Okay, so that constant raised to 25 is exponential. Okay, and log is basically the reverse of exponential. Okay, and here I'm now just creating a vector x is equal to 1 2 3 7 5 6 4 4, and then I'm running some mathematical function. I want min of that vector, I want max of that vector, I want mean of that vector, I want median, and I want mode. Only thing is, when you run mode, you'll not get mode, you're going to get something else, because mode is a function which gives you the type of the variable. As such, mode function you will have to write your own. I have given a small function which will see how we can compute mode, but otherwise min, max, median, mean is as same as what we use. Let's try out these mathematical functions. Now let's see some string manipulation functions. Again, string manipulation functions all available in all the tools. Okay, and here I would like to mention that when it comes to regular expressions is basically matching some patterns and writing some complicated pattern matching syntaxes. Most of the tools implement Perl regular expression in the background. Perl regular expression in the background. Okay, what we are going to see, some basic simple text identification, text search function, text replace functions, those things. But yeah, if it comes to complicated pattern matching, then it is Perl. So R makes use of Perl libraries in the background. Python makes use of Perl libraries in the background. Okay, it's another, Perl is another programming language, and the best part of that is regular expression is what is one of the best element of Perl. Okay, so here we are going to see some of, I'll not run all of them, but here I'm going to run a few of syntax. So str, what I've done is I have created a simple string variable where I have said a to z, and then I have again concatenated a to z. Now nchar is basically a simple function. It will say how many characters are there. So if I run that, it gives me how many characters. I am now here saying regular expression fg string. So here what I'm trying to do is I'm trying to locate the first instance of fg, where fg word comes in this string. So fg comes here at position 6. So when I'll run this syntax, it is going to give me, I'll just try running this much part of the code. So it says that if you see this element, it says the first instance is at 6. How many matches are there? 2. It's giving me that. Okay. And of that, I'm now just getting the first value. So it just gives me 6. This output is actually like a list. Okay. I want all instances to be found out. So I just change the function and I say greg expression. When I run this, let us see the output, greg expression. So see, you see the output is 6 and 32. Okay, I'm capturing this in a variable I, and let's see the I, a list. Okay, I want the output. So what is length function going to do? Length function is going to give me how many matches are there. When I'm saying 1 colon to that many number of matches, I want all those values. And because this output is stored in the first element of the list. So I'm taking the first element. So it is return me 6 is where FG is coming and 32 is where FG is again coming. If I want to now match ignoring the case, so I'm using reg expression and I'm saying ignore dot case is equal to true. If I don't say ignore dot case, for example, here when I have executed this syntax like this, if I would have executed this syntax like this, -1 is basically false. Okay, let me change the code again. So here when here what I have to do is say ignore the case and then match. So it has matched. Substring. It will basically get the string from the starting position till the last character, whatever you mentioned. So start from position 1 till 10. So here I'm saying substring. So that much part of this a string has been pulled out. I can use dynamic combination where I'm saying the starting point be identified based upon this pattern match. Instead of starting from 1, I'm saying wherever FG word comes up, start from there and then go till end. N char is basically length. So if I run this part of the code, it will start from 6th position and go till end of the code. So here we are all doing some basic matchings. Now I'm saying substitute FG by FG. Any occurrence of FG, I want to substitute it. Only this instance has got replaced. Second is not. If I want to replace all, I have to use gsub. Gsub will do all instances. So find and replace, yeah, replace all. So find and replace will do only find and replace the first instance, and then you have to keep clicking. But here I'm saying replace all, so it is doing that. To upper, quite often now when you do all these pattern matching, you would have now realized that case is very sensitive. At times you don't want to be bothered about case. Basically because say you are trying to search something and that word that you are trying to search, say it is say loan. Assume you are doing a text mining of the narrations of transaction data of your customers, and from text mining the narration of transaction of all your customers, as we are banking customers in our bank, whenever EMI goes, it will say loan EMI something. I want to find out of all the customers that I have, who all has got loan on them. I can do a text mining of my narration of all the transaction. Wherever the loan words come, I can say these customers have loans. Now this loan, assume loan is not coming as, some place it is coming as LOAN, and L is capital, all other small. Some place it is coming as LOAN all capital. Some place it is coming as LON all small case. Now these are the various combinations. Now if you're going to write a regular expression where you have to specify LOAN in various formats, somewhere L capital, somewhere all capital, somewhere all small, and it is quite possible loan can also come as L small, O capital, A small, N capital. It can come. For example, how it can come? For example, you are transferring fund from your own account to another bank of your own account, another account in some other bank. And the reason why you are transferring that fund is for loan repayment. Now here the loan is not being paid from this bank, but it is being paid from another bank's account. But the fund is here. And because you know tomorrow EMI is going to hit, by that time you want, so now you are typing, while doing NEFT transaction, you are typing LOAN, and by mistake L was typed small, O was typed capital, A was typed small, N was typed capital. Assume. Should I miss on that? So typically when we do text mining, what we do is either convert everything to small case or convert everything to uppercase. So to upper will convert everything to upper, to lower. If everything is in this case everything is small, but if there would be some things which are capital and something small, it would have converted. And if I want to split the string into multiple components based upon certain word, string split. So here you see it has got split and I got this. So these are various, some of the common, and I would say common and easy text mining functions. These are all common and easy text mining functions. When it comes to scrapping of data from website and then getting information, you will have to do more in-depth regular expressions. For example, we make use of star. When we do a file search in our machine, we use some name of the file and then star. Such star, rectangular brackets, underscore, question marks, these are all called wildcards. They have got different interpretations and you can create complicated search patterns using these wildcards also. That going to that level of text mining requires good amount of skill. So we'll stop at this basic level. Regular expression otherwise can become a full separate exercise in itself. Okay. So just try out all these syntaxes. A quick one, a couple of them you can try. I have what I've done is here, when you go through this presentation, I would suggest go type couple of them now. When you go through the syntaxes, for ease, what I've done is, if you see, I have put the comment, what this function does. Everywhere I put the comment. Okay. I is basically a list. I is a list. So this one, I is list. I am of that list. I am accessing the first element. If you recollect, single bracket and double bracket in list, single bracket returns a sublist. Two bracket returns a values of the list. So using this, I am getting the values, and then I am saying show me 1 to this. I could have typed this much also. In this case, I could have done this much only. It would have given me the values like this. But now I'm saying that I want 1 to this length. Okay. And this gives me output like this. Okay. So just try a few of them, which is here. A couple of them is okay for now. Then you can try the rest of them when you refer the presentation. Okay. So far what we have seen is functions which are inbuilt, and these commonly inbuilt functions are across all tools, but at times you may wish to create your own function depending upon your business requirement. So R allows you to create user-defined functions. The way to create user-defined function is, first step is you have to name your user-defined function. So you give some name. Now that is a function. So what you have to do is this name you have to assign and then say function. Name is equal to function. What does a function do? Function typically takes some parameters. So you have to specify the parameters, names of the parameters. Okay. How many parameters? So param1, param2, param3, bracket close. So these are put in brackets. Once you have declared what is the name of function, you have to write a logic of the function. The logic of the function is written between these curly braces. So you have here between this curly braces, you have to write your logic. Function always returns a value. Once a function is executed, it returns a value. For example, we saw many string functions. When you execute it, it retains some value. Okay. So it has to return some object which will contain value, or it has to return a scalar value. Okay. So you have a return syntax, return statement. The moment a return statement is encountered, it means the function has to come out. That means that logic is completed and you are returning out. If you don't write this statement, the last code statement that gets executed, value of that is returned back. Okay. Now when we have been using many of the functions, so far we have used many functions in R. For example, read.table. We saw read.table has many arguments. But how many arguments we were using? We were using file, we were using separator, we were using call.names, call classes, header, string as factors, but still we did not use many other parameters. And at times some functions when we called, we did not pass all of them. Like strings as factors, we have not been using across all the read.table syntaxes. When we don't use a parameter, typically what happens is default value is assigned. And if you don't supply a value, default takes precedence. If you supply a value, your value takes precedence. Similarly, when you create your functions, you can have default values for some parameters or for all parameters, depending upon your requirement. So this is the other way of writing the function. Okay. As I mentioned that there is a mode function. When I was doing it, I could not find mode function. So I wrote a simple user defined function. So what I'm saying, I want a mode of a column. A column is basically a vector. So I'm taking that as a input. One column input I'm taking, and the name given to that function is get underscore mode. This is the name that I'm assigning. Braces, here I open the logic. So here table, what does table do? Table gives you a frequency distribution. So that frequency distribution I am storing in a temp. When you get a frequency distribution, the categories, for example, when we did occupation, salaried, self-employed, professional, all those are categories. Those becomes names, key value, and the corresponding frequency becomes the value. So when you do names, it will give the name of the categories. But now I don't want to, in a mode, I don't want all the categories to be shown. In a mode, I want that category to be shown for which the value is the frequency is the maximum. So what I am doing is max of temp returns me the max value of all, and that I'm comparing row by row for all the rows. Wherever that row number and the max matches, that index will come and corresponding name will be printed, and that's how I get the mode. So this is the last statement. What did I say? If you don't specifically say return, the last statement execution, whatever is the value of the last statement becomes the return. So here, because I did not use the return syntax, this will be returned back, and that will be my mode. This is the logic that I have written here. Yeah. So let's quickly see this function in execution. Get mode. So here when I say get mode, whenever you use a function, before using a function you have to compile it. So I say I compile it. Now what I'm do is, let me create a vector, say ABC. To this vector, let me give some values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 9 is 1, 1, 1. How many ones are there? 4. 7, 7, 7. How many 7s are there? Mode of this data will be 1 and 7. It's a multimodal data. What is multimodal data? Multimodal data is one where there are more than one peaks. More than one category which has got maximum frequency. So I am created this multimodal. Now instead of passing LRDF balance, let me pass this ABC. It shows me 1 and 7. Yeah. So I got my mode.